Volume has more than just the use of figuring out how much something is filled, like what's it take to fill. Volume can also be used in the concept of density. So we're going to apply the definition of density to calculate density, mass, or volume. So let's look at density first. Density is when you compare the mass of something to its volume. So density equals mass divided by volume. Traditionally, you will see it using the first letter of each word. So the definition of density is the amount of mass per unit of volume. So you can see that right there. The amount of mass per unit of volume. Of an object or substance. And I tried really hard not to do that because I'm running into the wall, but there it is. I got that way too close. So how do you measure density? What do the units look like? Well, mass is measured in weight, and volume we know is in cubic units. So an example would be grams per cubic centimeter, pounds per cubic foot. So those are the measurements that you would find in density. So what would that look like as a question? A box has a volume, so here's your volume, and a mass of 25 grams. What is the density? So here's where it's going to ask you for the density. But they're going to give you a volume, or you're going to have to calculate a volume, and they're going to give you a mass. We know what volume is, so this is kind of review. It's the amount of space an object or substance occupies. The amount of space an object or substance occupies. We know from past experience that volume of, let's say, a prism is the base area times the height. So in this case, the base was a square. The height, there's something wrong with my numbers, but that's okay. My height is 4. Or, sorry, my base would be a rectangle and my height would be 4. What's the unit of measure that we use for volume? So we know very certainly that it's cubed, so centimeters cubed, feet cubed, meters cubed, inches cubed, etc., etc., etc. Now you'll notice our definition says objects or substance. So sometimes our substance is a liquid. And it seems that we don't really, like, how do we get a liquid to become a volume? Because 1 cubic centimeter in a milliliter. So milliliter is a volume as well, even though it doesn't seem like it is. So what does the question look like in this case? We would need to know, remember, density is mass times, or mass divided by volume. So if you were looking for volume, you were going to need some kind of mass. So here's the mass. They would give you a mass of 18 grams, and they would give you a density of 12 grams per cubic centimeter. So what's mass? Mass is the amount of matter an object or substance contains. The amount of matter an object or substance contains. So how do you measure the amount of matter? you're going to measure it in things like grams or pounds or ounces, things like that. Again, density equals mass divided by volume, so if you're being asked for the mass, they're going to need to give you a density. The density is 7.86 grams per cubic centimeter, and they're going to need to give you a volume, or you'll have to calculate the volume. Anytime volume is a given value, it's either given as a single value or it's given because you've calculated it. So let's look at some examples of how this works. A cylinder has a volume of 100 cubic feet, so there's my volume, and a mass of 25 pounds, so there's my mass. I'm going to circle both of those actually. And it says, what is the density of the cylinder? So we have a D, a V, and an M. So density equals the mass divided by the volume. So density is the mass, which was 25 pounds, divided by the volume, which is 100 cubic feet, and we divide or simplify. So that's going to give us 1/4 of a pound for every cubic foot. So if you think about a cube that's a foot by a foot by a foot, that would weigh 1/4 of a pound, the same weight as a hamburger from McDonald's. Now you don't have to make it a decimal, you can definitely make it a fraction. But the density explains, like if you have something this big and it weighs the same as a hamburger, it's not very dense. There's a lot of air inside of it. It's kind of fluffy is the best way to think about it. A block has a mass of 81 grams and a density of 54 grams per cubic centimeter. What is the volume? So density equals mass divided by volume. So the density is 24 grams for every 1 cubic centimeter. The mass is 81 grams. We want to know the volume. So this is a beautiful proportion that we can just cross multiply. So we get 54V equals 81. So our volume is going to be 81 divided by 54. So that's 1.5. Now think about this. Over here, the 54 had a gram. So we have a gram on this side, and over here, we had a gram times cubic centimeters. So the grams are going to cancel, leaving you cubic centimeters, which should make sense because volume is in cubic centimeters, or cubes. Now, there are plenty of people who do not like the whole, oh my gosh, I have to set up a proportion, why can't I just do it a different way? Well, you definitely can. We can look at what's called a formula tool. So we know that density is mass divided by volume. So here's density, mass divided by volume. So what if you want to find mass? So then mass is density times volume. What if you want to find volume? Then volume is mass divided by density. So you can definitely rearrange your formulas based on the questions at hand. It's up to you how you handle that. Sometimes the data doesn't come in a question, standard sentence question. Sometimes it comes in a chart. You gathered data about a wood log that is approximately cylindrical, that's important to know, based on the data, that should say data, in the table, what is the density of the log. So we know we want density. We know density is mass divided by volume. We know mass is a weight. So let's go over here. Oh, here's our mass. So mass is 791.7. We need a volume. Okay, we don't have a volume, but we can get a volume. So the first thing we're going to do is we're going to calculate the volume. The volume of what? The volume of a cylinder. Pi times radius squared times height. So pi times, okay, notice that they give you a diameter, so the radius is 1.5 feet. So our radius is 1.5 feet that we're going to square, and our height is 4. So we're going to multiply all this out, and we're going to get about 28.27 cubic feet. So now we have our volume, we have our mass, we can go back and find our density. So this ends up being second. So density is our mass, 791.7 pounds, divided by our volume, 28.27 cubic feet. And we're going to actually divide those out and round them to the nearest whole number. I'm not sure why we're rounding. I'm looking at my key here, trying to figure out why we went to the nearest whole number. Because we got lots of zeros. That's why I've got a whole number on there. Okay. So it's about 28 pounds per cubic foot. Now remember our previous example, we had a cubic foot that weighed 1/4 of a pound, and now we have a cubic foot that weighs 28 pounds. So in the same space, we have more weight. That means it has to be closer condensed, more dense, less fluffy. So let's look at our last example. Lead has a density of 11.5 grams per cubic centimeter. A rectangular block of lead measures 4 by 5 by 2 centimeters. Find the mass. So we are being asked to find the mass. So we are missing the volume. This is going to become our volume. We know density equals mass divided by volume. But we also know, using the formula tool, if I'm really looking for mass, I can take the density times the volume. So why not just try that one? Again, I already know the density, I don't know the volume. So the very first thing I need to do is find the volume. So the volume of a block is the area of the base, which is a rectangle, times the height. So length times width times height. So basically 4 times 5 times 2. So that's going to give me 40 cubic centimeters. So my mass is my density, 11.5 grams per cubic centimeter times 40 cubic centimeters. So you can see the cubic centimeters cancel. So 11.5 times 40 is 460 grams.